So my name is Becky Humphrey. I'm the co-founder of Nevada Science Center. I'm a scientist, actually a paleontologist of my training. So here we're just here with the Nevada Science Center to let you celebrate Nevada and all things cool about Nevada science, the history of Nevada. So we wanted to bring with you the Hoover Dam, and I'm here with
Dr. Josh Bondi, and I'm the curator at the Las Vegas Natural History Museum.
Here's a historical photo of how they would go out to survey where this dam should be put in. So like Dr. Bondi said, the rocks had to be right, so strong enough rocks, and then a great place to build, to have enough space for this reservoir. So here are the men staking out where we should do this here in Black Canyon right behind us. So before, 1935, Lake Mead was just the Colorado River. So in order to build the dam, they had to first divert the river. So where's that water gonna go? They had to blast through these very strong igneous or volcanic rock that would later be the foundation for the dam, but they had to divert it. So here's some pictures of some explosions going on. And you see these tunnels way down here. So two on each side, these were the diversion tunnels. So 1.5 million tons of rock was excavated in 13 months with daily blasting explosions. High scalers are the men that were hanging off this edge of the cliffs on ropes to prepare the rocks for the blast by inserting the dynamite. So 4 tunnels, like I said, they were massive, 56 feet in diameter, averaged 4,000 feet long to divert the river. So after the river was diverted, there was a ton of sediment, river sediment at the bottom, 138 feet of sediment they had to remove to get to the bedrock. You have to have a strong base, obviously, to hold up and support a dam of this size. So they had to take out all this sediment to get down to the bedrock, and then they could start pouring the foundation. So the foundation is actually 660 feet wide of concrete.
All right, so like Becky mentioned, one of the purposes of building Hoover Dam originally was for flood management. So the Colorado River, during spring runoff from all of the snow that goes up into the Colorado Rockies and the other Rocky Mountain ranges from which the catchment of the Colorado River drains down into this part of the Southwest deserts, in this case the Mojave Desert, those seasonal floods were always a problem for settlers, for people that lived along the waterways here in the Southwest. And so flood management is always one of those side effects of dam management, is trying to control the outflow of water. That's a whole completely different topic if you want to get into flood management. So knowing that at some point Lake Mead could potentially fill to capacity and would potentially, during one of these great big floods, maybe one of these 100-year events, 500-year events that we talk about here in the Southwest, that there would be a need at some point for flood management of the dam itself. So here we have excavation of what are the overflow outlets. And so over the spillways, there's great big tunnels that are over, about 30 feet in diameter that are lined by concrete that were engineered so when the lake did reach capacity and water went over the edges of the spillways, then these would funnel the water around the dam to keep the dam intact. And so these were designed to make sure that the dam never actually washes out and it remains safe. A new interstate system has been planned for going from Phoenix all the way up through Nevada. And so as part of that, a bypass had to be built to Hoover Dam, because if you have cars driving over the top of the dam, it's one lane each direction. You can imagine the traffic nightmare trying to get between Las Vegas and Phoenix, and it's down to one lane each direction. And especially if a great big truck's trying to make its way over the dam, you have to get held up while that big truck makes its way across. So a modern feat of engineering is the Mike O'Callahan-Pat Tillman Bridge. So this is a perspective looking from Hoover Dam at what is now I-11 US 93. And so this is still interstate highway, 4 lanes of traffic. As you're driving across it, you don't even know you're going over Black Canyon. And so this is the highest concrete span bridge at least in the Southwest. It's the second highest in North America. There's one in Colorado, which is a little bit higher than this one. Just to give you some perspective, the Black Canyon, the Michael Callahan, Pat Tillman Memorial Bridge, it's 100 feet taller than the Golden Gate Bridge, which spans the mouth of the San Francisco Bay between the South Bay and the North Bay. So again, the construction on this, being a Southern Nevada resident, being able to watch this thing under construction was an amazing feat of engineering. At some points, it looked like they were actually working vertically, pouring the concrete for the arch for the roadway above.